You are welcome to the part 2 of this video on the Thevenin'S theory. In part 1, we concluded on how we need to find VTH and RTH, and we looked at that practically. And then we ended with how we are going to find it using our hand by calculation. So now, we concluded that we need to find VTH. And how are we going to find VTH? Number 1, we are going to remove the element we want to find the current in. Try to watch the part 1 so that you can follow. So you remove the element you want to find the current in. Number 2, we are going to find VTH. But the question is, how are we going to find VTH? We will apply any of the theorem, but because this one is dealing with simple circuits in, say, applied electricity, I just want to introduce you to maybe applying basically the Kirchhoff current law and the Kirchhoff voltage law, so that you can find the VTH, right? So it means that you need to understand the Kirchhoff current law and the Kirchhoff voltage law as we did previously. Make sure you watch the video on Kirchhoff laws so that I can, because Thevenin's theorem, in the process, you need to apply another theorem to try to find the current or the voltage or anything that you want to find, right? So try and watch the video on Kirchhoff. So now we will remove the element and we are going to apply KCL or KVL to find VTH. There are various ways. Sometimes you can apply something we call mesh analysis and all, but not introduce you to those things yet. So basically, you're just going to use the Kirchhoff laws to find VTH, right? So basically, that's what we are going to do. Remove the element, apply Kirchhoff laws, and find VTH. Now, the main thing is that, don't forget, let me put that as a note. And what you need to do when you are finding the VTH is that the element that you remove, you have to fix VTH where you remove the element. So the place that you remove the element, you fix VTH there. And basically, when you fix VTH there, you can give VTH any direction. And I'll talk about that. Number 2, one thing you should note is that you need to treat VTH as a source, right? Because you are going to apply the Kirchhoff voltage law. You are going to put sources at one side and current times resistors at one side. Now, VTH is going to be treated as a source. So when you put the source at one side, you have to make sure you put VTH at that side. Now, one main thing you should also know is that VTH is an open circuit voltage. It's an open circuit voltage. So, no current flows where VTH is. And I want you to note this very well. See, VTH is an open circuit voltage because when you remove the element and you take a voltmeter, the voltmeter is going to measure the open circuit voltage. So you should know that because it's an open circuit voltage, no current passes where VTH is because the place is open. So don't forget that when you are finding VTH. And we'll practically do examples and you understand what I mean by that. So first you remove the element, then we are going to apply Kirchhoff laws to find VTH. But what we'll do is that we'll first fix VTH where we remove the element. Then we are going to treat VTH as a source voltage. And after that, we are going to note that no current actually passes where VTH is because VTH is an open circuit voltage. So basically, that's how to find VTH. Now, let's look at how do we find RTH. Now, number 1, note that all the steps you follow to find VTH on the main problem, when you finish, everything ends with VTH. Because if you are using a voltmeter, you just bring the voltmeter to do the measurement. When you finish, you are done with the circuit. What you need to do is that you need to go back to the circuit again, and though we have already removed, but you should know that you will remove the element, right? The element that has already been removed. Number 2, according to the Thevenin's theory, you have to measure the resistance, but before that, remove all sources. right? So the next thing we are going to do is to remove all sources. Now, how are we going to remove sources? We all know that in a circuit, is either, let me call that A, is a voltage source, or B, is either is a current source, either a voltage source or a current source that we may find within a circuit. The question is, how do you remove a voltage? So if I have a voltage like this, and I want to remove the voltage, the only thing is to short circuit the voltage. So if it's a voltage source, we are going to short it. But how do I remove a current source? If I want to remove a current source, I need to open it so that no current actually flows. So if it's a current source, we are going to open it, short it. If it's a voltage, we will short it. If it's a current source, we are going to open it. So note that. So remove the element first, then we'll remove all sources. If it's a voltage source, we'll short it. If it's a current source, we are going to open it. That's step 2. Now, step 3, the next thing we'll do is to find the total resistance. And we are done with RTH. And make sure you go and watch the video on things in series and things in parallel, because that is what is going to help us find things. How to find total resistance is going to help us. So now we know the basic concept of Kirchhoff laws, we know the basic concept of finding total resistance. It means Thevenin should be easy for us. All that we need to do is to remove the element. And I'm sure you can easily remove the element. Let's look at a practical circuit and apply the Thevenin's theorem. And then you understand what I mean. Let's look at an example, question 1. Let's say we want to apply the Thevenin's theorem to find the current in this 10 ohm resistor. And in this question, I want us to first find RTH first. Now, the next thing, the main thing we know is that I'm going to draw the circuit, and this 10 ohm resistor, because I'm interested in finding the current in the 10 ohm, that resistor that you are interested in finding the current or the voltage across it, you remove that element. That's the first step, right? I want us to do RTH first because it's very simple to find RTH. So I'm going to remove that. So I have this now. Now the next thing is that here is 15, here is 5, here is 8, here is 12. The next thing after removing the element is that I'm going to remove all this. So you see there's a source here, there's a source here. So I'm going to remove them. Now because it's a voltage source, I'm going to short it. So you have shorted the place. This one too is a voltage source, so I've shorted the place. So basically this is all. The next step, as we just looked at, we have removed the element, we have removed all sources. This question was only a voltage source, so we have shorted all of them. The next thing is to find total resistance. But I want you to note something about RTH. One thing is that I want you to note that when finding RTH, the terminal is not open, right? RTH is not an open resistance. Because if you put an ohmmeter there, as I said, it actually pushes an amount of current. So that place is filled up. So to help students mostly know that when you are finding RTH, you are finding RTH at this terminal. One thing is you should know that this terminal is not an open place because your ohmmeter is going to be there. For the VTH, it's an open circuit voltage you are measuring, right? So to help students most of the time, we assume that RTH is the resistance we are finding here. So I draw a box there. Just this one is just to close up the place so that you know it's not open. Actually, Thevenin says RTH is the resistance seen at that terminal. What it means is that if you look at this terminal, the total resistance you see is the RTH. So always fix RTH there to close up the place so that you know that the place is not open. So now that we fix RT, then we can easily find the total resistance now, because the first step is I've removed the element, I've removed all sources. I'm now going to find total resistance. But I note that when I'm finding RT, the terminal is not an open place. What it means is that 5 and 15 are in parallel. They are not in series. You know, if here is open, that's when maybe you may think it's in series, but it's not open. So this 5 and 15 is in parallel. And if you have watched our videos on things in parallel, you realize that if I can go around 5 and 15, then I know that they are in parallel. So I put this 5 times 15 over 5. Let me write that well. So I have 5 times 15 over 5 plus 15. And this is going to give me 15 over 4. So you can see 5 and 15 are in parallel. Then I can also see, if you remember when you are studying total resistance, I always say start from the ends of the circuit, right? So I started from this end. I want to start from this end then. So what is 12 and 8? So 12 and 8 are in parallel. 12 times 8 over 12 plus 8. And that gives me 24 over 5. Now, if you would draw the circuit again, you realize that RTH is here. Then when I put the two resistors, let me put the answer on this. And these two resistors, let me put the answer on this. So you realize that here becomes 15 on 4, and here becomes 24 on 5. And we can easily see that this and this are in series. So it's going to be 15 on 4 plus 24 on 5, and I'm going to get 171 on 20. So RTH is 171 on 20. Simple, right? We have removed the element, removed all sources, and we are finding total resistance. Watch the video on series and parallel, you'll be able to easily find this total resistance. So we are done. The next thing is to find VTH. So now let's find VTH. So in finding VTH, I'm done with this circuit. This circuit, I'm done with it because it was just for RTH. So in finding VTH, I'm coming back to the question and I'm coming to remove the element and I'm going to find VTH there. So let's look at that.